Hello everyone, this is the Unit 9.1 Introduction, and this is the very first section of our course. It is Chapter 9 because it follows the BC Calculus material which goes through Chapters 1 through 8. And so what we're going to talk about in this section is the three-dimensional coordinate system. For some of you this might be relatively new, and for others of you, you might have seen some of this in the past. The good news that I can tell you is that this is a very easy section, very straightforward. There's not a whole lot here. But I will warn you that as we move, especially through Chapter 9, you're going to find that there will be little bits and pieces that are going to start building on themselves, and sometimes that gets a little bit cumbersome to deal with. You want to make sure that even if something's really easy, something like finding the distance between 2 points is a really simple calculation. But little things like that will come back in a much more complex way later on. We'll also talk about some ideas like projections. Those projections that we talk about are really building blocks for stuff that we do in the remaining chapters. Chapter 10, they'll come back in chapter 12 and 13. It just depends on the topic, but there's a lot of connections to this stuff, which initially feels very, very simple to do. So don't overlook that. Don't gloss over it too much. I want to make sure that you all have a great foundation in this as we move forward. So as we look at the three-dimensional coordinate system, there's so many similarities to the two-dimensional coordinate system that we have. For instance, we have points that in the two-dimensional system that is x and y, and of course that allows us to go along the x-axis, go along the y-axis, identify a point, and we have this unique relationship there, this one-to-one correspondence. Well, in the three-dimensional system, we have exactly the same thing, except there are three pieces to it. And A, B, and C, yes, you could use, but really what we're going to use is X, Y, and then we're going to add the Z. So there's a new axis here, Z. It allows us to go into space. It allows us to do way more with what we are studying. But really, there's this huge connection between what we did in single variable calculus, which is A, B, and BC calculus, and what we now do in multivariable calculus. And it's really remarkable what this opens the door to. So little things like, you know, finding instantaneous slope along a curve. Now we're going to find instantaneous change along a surface, and it's going to be of any direction that we can imagine. Now, the idea here, though, is that we need to be able to identify a point in space or a line in space, and so this three-dimensional coordinate system is really important to us. Some of you are going to be fine with this. Some of you are going to be able to visualize this. You can close your eyes and see it. You can just sit there and you can visualize what's going on. And others of you, it's going to be very difficult. You're going to be sort of trying to almost turn your head or kind of turn, maybe your iPad or your book or something like that, your piece of paper to try to visualize, excuse me, what's going on. And that's just, we're all wired differently. And so I just, encourage you to try to explore this as best you can. My hope, even though we're in this distance learning environment, is that we will have the opportunity to use some apps on our iPad. There are some really powerful ones, and so we'll be discussing those hopefully soon within the first couple sections here. And I hope that those will help you kind of gather what this three-dimensional system looks like. But really, in a traditional sense, you have this z-axis, which is typically the whole idea of up or down. Again, this entire axis could be just completely rotated and flipped, but for the time being, the z-axis is, let's just say, up and down here. The x-axis is drawn here, and the y-axis is there. And again, keep in mind that you can twist and turn this all you want, and it really won't change. There is a positive portion of the z-axis and a negative portion. There's a positive portion of the x-axis and a negative portion, and so on. This drawing is in there. We'll do some stuff with trying to figure out where certain vectors in space point, and that's called the right-hand rule. That's what this is. This picture is showing you. It doesn't make any sense right now in this section, so don't worry about it right now. But soon, what we will do is use that, and unfortunately, because of the distance learning environment, I may not be able to see all of you try this with your hands. It's kind of a funny experience as we're all together. But again, this is the right hand rule, which you don't need to know at this moment, but in a little bit you will in the next couple sections. Again, here's now the step from 2 dimensions to 3. So in 2 dimensions, we have an XY plane. There's one plane. There are 4 quadrants, to the plane. All students take calc if you all remember that. So again, let me just draw this. So you have, excuse me, your X and Y axes. You have your quadrants, so 1, 2, 3, and 4, and the entire thing is one plane. It's the XY plane. Well, all of a sudden in space we have more complexity. So we have actually 3 planes. We have the normal XY plane. We refer to this plane a lot as we study in space because it is sort of the building blocks. It came first. We learned single variable calculus. Now we're learning multi. Then we also have the YZ plane and the XZ plane, and these are very important, all 3 of these, to know because we will be utilizing them as we analyze space. And you just have to make sure that you're well aware of what we're talking about. For instance, as we get into the next couple units, we will do some instantaneous change, and some of the instantaneous change that we do in space will be in the direction of one of these planes. So anyway, keep in mind the 3 planes of space. Here's I don't know, a house picture of what's going on. I'm not really sure how that exactly helps. Okay, over here, we don't have quadrants anymore. We now have octants, okay? Now, let's just assume for the moment that this is X. So the X-axis is here. Let's assume then that the y-axis is here, because again, this could be all sort of different depending on how you turn this. Oh, you can't see the z at all. Let's do the z-axis. Oh, I wanted a different color. Hold on. Here we go. Z-axis is here. Okay, now let's also assume that the positive x is here. Maybe I'll write that in. Let's also assume that the positive y is here, and then the positive z. Okay, so hopefully that makes a little bit of sense to you. If that's the case, then originally, like if we were to look at this sort of bluish, purplish plane, that's our XY plane. So that's sort of based on what we have studied in the past. This little section here would be quadrant 1. Well, now what we call that is octant 1. Okay, so that's the first octant. Now over here, we have our second quadrant. If we were in single variable calculus, if we were not in space and we were on a 2-dimensional plane, but now this is going to be the second octant. This is the third octant. Oops, sorry, hold on. This is the third octant over in this little region. This is the 4th octant, okay? Now again, those 4 follow the 4 quadrants that we have always studied in space. So those are really directly tied to the 4 quadrants. Okay, now what we do is we jump below the first octant. That is now going to be our 5th octant. Then we have over here our 6th. The 7th is underneath the 3rd right there, which I can't show you very well. And then we have the 8th, which is going to be underneath the 4th. Okay, so that's sort of how it works. On a scale of importance, this is pretty low. It's important to know. I want you to know that. I want you to know a lot about multivariable calculus. Are you going to have a bunch of test questions on it? No. So it's not going to be like super helpful academically, I suppose, when it comes to getting a high grade, but it's important to know. I want you to know it. So there you go. Those are your 8 octants. Okay. All right, let's jump to the next page here. So let's talk about plotting these points. Now, you're traveling along an x-axis, a y-axis, and a z-axis, and that's really how we think about graphing them. And I'm no artist at all, and I can guarantee that I will never put you in a spot in this course where I'm going to test you on your artistic ability. Okay? My sister ended up getting all of those genes. I can just do some math, but I really can't draw very well. So you're probably going to do better than I will. I will not judge you at all for your artistic ability. So let's say we're going to graph 2, 4, 5. Okay, the way I think about this is that I'm going to come off the x-axis in the positive direction 2 units. Okay, then I'm going to go 4 units along the y. 1, 2, 3, 4. So this is that's sort of a point, I guess it is a point in the xy plane. Like if we were normally in two-dimensional space. Okay, so that's 2, 4. What we're going to do now, however, is we're going to, project that up along the z-axis. Now we're going to go 5 units, which is going to look weird because we're already away. We're drawn away from the z-axis. So yes, we're going to go. Let's see, 1, 2, 3, 4, 5. We're going to go 5, but because we've been drawn along the x and the y, it may look like, I don't know, maybe that point then is going to be, I don't know, somewhere. Hold on, my pen just got messed up. It's going to be maybe like here-ish, okay? So maybe that's the point 2, 4, 5, roughly, okay? Again, you're in this space element. Some of you have had drawing classes and you're sitting here going, yeah, this is an easy deal to do. You can try the other one. I'm not going to, well, maybe I will because it's negative. Hold on here. So let me pause. I'm going to draw out the grid. Okay, so if it's negative, what you're going to do then is you're going to travel along the negative portion of it. So 1, 2, 3, 4. So that's going to be -4. 3 units, 1, 2, and 3. So maybe, I don't know, around there is -4, 3. And then what you're going to do is go 5 units down on the Z. So 1, 2, 3, 4, 5. But again, that's going to look maybe like a projection here. So I'm going to call that my point, -4, 3, -5. Again, I just want you to be aware. I'm not going to be testing you on being able to graph these kind of things. I want you just to be able to kind of grasp the idea of it and be able to sort of picture it as we talk about all of these points, as we talk about the octants, as we talk about space. It's just so important that you can grasp the idea. Now, this little picture here that we have is really just what I showed you when we were plotting those points. The idea here is that, I often think about the XY plane just because of how we've built calculus over the years or how we've built math over the years. That's really what we learned first. So I think of, okay, let's plot a point in that plane and then let's project it up to the Z or down or whatever it is to get to our desired point. So I often start with that plane. You certainly could start with, let's say, a point on the XZ plane and project it out along the y-axis. We'll do some of that as well. It's just not quite as natural for us yet. So that's really all of this particular picture is communicating. It's just important information. And I did mention as well, the idea of a projection is a really central idea to some of the calculations that we're going to do in not too long. Okay, let's talk about graphing. Now, I think this is a remarkable idea because it's so simple, yet our world of graphing is going to dramatically change this year. And I'm excited for you all to experience that. And again, we're going to utilize some of our apps. I ended up adding in some pictures here to show you. I'm not going to walk you through the apps yet because I don't think that you'll probably have them on your iPads yet. But I'm really hoping that even though we're distance learning, you can get these apps because I've asked the school to put them into the App Store so that you're allowed to utilize them. So let's start here with just a simple graph, okay? we have y equals 5. I think way back in the day, you'd say, oh, is that a horizontal line or a vertical line? You know, you'd get confused back when you were young pups in whatever class. But we know it's a horizontal line because y is always 5. Y is always 5. And x could be anything. And I always told my students when I used to teach algebra to my sixth graders, I'd say, well, what's y right here? And hopefully they would say 5. And I say, good. You know, what's x? They'd say, oh, x is 2. And I say, okay, what's y right there? And they'd look at me funny, and we'd say, yep, that's 5. And then I'd say, okay, well, let's say x is 4. And what's y here? They say 5, and I'd say, good, and x is -1, and so on. And they would get the idea that this equation right here dictates that y is 5 always. It has to be, but x is not defined in the equation. And if x is not defined in the equation, then x can be anything. It doesn't have any rules. So y is always 5. Okay, now let's change our view here from 2 dimensions and let's go to 3 dimensions because everything I just said still holds true. If our equation, and keep in mind that the equation has not changed, okay? So you have to know we're either talking about 2 dimensions or 3 because if I say graph y is 5, you could say it's a line on a plane, or you could say it's a plane in space, and both are true because I haven't specified what I'm talking about in regard to a two-dimensional view or a three-dimensional view. In 3 dimensions, y is always 5. It doesn't change. Y is always 5. But both x and z could be anything. So let's just take the same approach. Let's say I ask my students, okay, what's y? 5, good answer. What's x? Maybe x is 1. Maybe z is 4. I don't know. It's kind of hard to tell where it is on the plane, but you get the idea that you could pick a point anywhere on this plane and y is always 5. X and z could be anything because they're not defined. Okay, so it really changes our view of this. It's such a simple change, yet the object is very, very different. Now, keep in mind that if you were to kind of go back to the two-dimensional view, it's a line, and that line is right here in space. Okay, because again, that's the XY plane. And so if we were to take away z, we get that line that we've sort of always studied. Okay, and then here's another example. Here's z equals 3. That's a line, or excuse me, that's a plane in space, and you can see that z is always 3. X and y can be anything. Okay, so kind of some interesting things there. You can sort of see that there are general rules to this. I think you all are clearly smart enough to be able to generalize this stuff, and we will study planes a lot. So anyway, that's the introduction to section 9.1. The next video will be on some of the examples.